It's your math teacher, Mr. Boyd, back at it again today. Today we're going to be talking about equilateral triangles and isosceles triangles. So here's our lesson title. Go ahead and get that down, and let's start talking about what these things are. Okay, we can break down the words. Isosceles, probably hard to break that down into its roots. But what I'd like you to know is that an isosceles triangle is a triangle where two of the sides are the same length, and then you have some third side which is some different length. Okay, for equilateral, that one we can break down a little bit easier. Equal, okay, it's equal, that's pretty easy to see. And then lateral means sides. So it means that all the sides are equal. So something like this, and you've definitely seen that before. Boom, 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 maybe it's 7, 7, and 7. All equal sides. One of the cool consequences of that is that if all the sides are equal, then all the angles are also equal. Okay, so let's get into what we're going to do with these, and you'll see some example problems. Today we're going to see a lot of test-style questions, so hopefully that'll get you prepared. Okay, before we do that, let's make sure we remember this. If you take a triangle and you add up all the angles of that triangle, how many degrees are we going to get? Okay, you should remember that's 180. We've talked about that a lot. That's going to be really important today. If we don't know that, today's not going to make any sense. Okay, so now here's a little more formal explanation of what these are. For isosceles, specifically it has one pair of parallel sides. That means that these two sides, this one and that one, are the same length, and then you have that third side which is different, like I talked about in the intro. For equilateral, all the segments, or all the sides, boom, 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 and all the angles are the same. So with that in mind, I'd like you to try to answer this question down here at the bottom. How many degrees are in one angle of an equilateral triangle? Okay, remember, we know there's 180 degrees in the triangle, and we know all three angles are the same. You may need to pause the video and try this and use a calculator if you need to. Okay? All we have is 180 degrees. We're splitting that up over three angles, and that's going to be 60 degrees. Now that's an important fact to have in your notes, because there's a lot of times in a question they'll say, well, it's an equilateral triangle, and then you're asked to find a bunch of angles. Automatically, you know all of these are 60, and that makes it a lot easier because you have more information that otherwise you may not have realized that you had. Okay? Now let's talk about what these are called, or what all the different parts of an isosceles triangle are called. So we got the legs, we got the base, so legs are the two sides. The easiest way for me to remember this, at least, is if I have a person, and here's the person, and you look at, like, literally their legs. Hopefully you know that a person's two legs are the same length. Okay? So those are the same. Usually that distance between your feet is some different length. So that's a way you can remember the two that are the same are called legs. The one down here is called a base. The two angles that are touched by the base, right here and right there, we call those base angles, and then that sort of odd man out is called the vertex angle. So take a look at this for a minute, and I want you to look at the angles. And I'll tell you that in any isosceles triangle, there's always two angles that are congruent. That makes sense. In an equilateral triangle, three sides match and all three angles match. In an isosceles triangle, two sides match, and that's why two angles also have to match. Or when I say match, I mean they're congruent. Okay, so can you tell by looking at this picture which two angles are going to be the ones that are congruent? Okay, you should be able to tell that it's this one and that one, and then this one up here is different. So I'm going to put a different marking on it to show that. Okay, and that's another fact we can use and we'll be tested on. We're going to see if we can answer questions by knowing that fact. Alright, let's try to use our understanding that we have of isosceles and equilateral triangles to try to answer this question. Okay, we're given a diagram, and we need to explain why triangle ABC, that's triangle ABC there, we need to explain why that's isosceles. Now, the first thing that jumps out at me are these little markings here. And they're little arrows. Do you remember what that means? Not that they're the same length, because look, those are lines. They go forever in both directions. It's just saying these two lines are parallel. Now that should jog our memory. That's what our whole last unit was about. We talked about parallel lines and the angle pairs that are formed on parallel lines. So I'm thinking like corresponding angles, same side interior angles, and alternate interior angles. Those were our three main ones we talked about. So maybe that's going to come up here. The other thing I notice, isosceles means that two sides are the same length, but I don't see any sides marked on here. And so that probably isn't going to relate necessarily to how we're going to answer the question. So I'm going to look at this, and I can see that this angle up here, angle XAB, is the same as ACB. And so that's not necessarily helpful because this one's on the outside of the triangle. But here's what I could do. I could look for another angle that's the same as those two, because we remember an isosceles triangle has two angles, the base angles, two angles that are the same and one angle that's different. So I'm looking for an angle that's going to be the same as this one. And it turns out that angle is right down here. Now you may want to pause the video and try to give your own explanation of why that is before I give it to you. Okay, here's my explanation. Angle XAB, that angle up there, is congruent to angle ABC. How do we know that's true? Because they are, look at this, here's the transversal, they're on different sides of the transversal, both angles are in between the parallel lines, those are alternate interior angles. So because they are alternate interior angles. Okay, so now I've got that those two are the same. I have two angles that are the same. That's enough to say that this is an isosceles triangle. So how will I explain that? I'll say since angle ABC is congruent to angle ACB, triangle ABC is isosceles. Okay, done. That's our explanation. Okay. Now let's get into some numeric type questions. So in this one we're asked to solve for x and y. First of all though, we have to identify what we know about this triangle. So is it equilateral? Is it isosceles? Or is it neither? Is it something different? So look at the markings on the picture and try to figure out for yourself what this is. Okay, the thing that jumps out at me is this little marking right here and that little marking right there. That's saying those two angles are the same. That angle's obtuse, so clearly it's different. If two angles are the same, that means this is isosceles. Now check out how easy this is. At the beginning, we said every triangle would have an angle sum of 180. I already know 110's right there. So I'm going to subtract off the 110. That gives me 70, and these two angles are the same. Now some people say, wait, that means that's 70 and that's 70. But that's not the case, because that would add up to a number much larger than 180. So what we do is we divide this by 2, and we get 35, and if that's 35, and that's 35, now we meet the criteria of the question. Because 35 plus 110 plus 35 does add up to 180, and these markings said that whatever number we use for x needs to be the same for y, and we've done that, so that's how it goes. Now, this is a really normal test-style question, so make sure you're tracking with this and bring questions to class if you don't understand, okay? Alright, let's try this one. Make sure you pause the video, take a chance to write it down, because remember, we need to have good notes. If we don't have good notes, how are we going to be successful in our assignments, and how are we going to be successful at asking questions? Okay, so get your video down. Now let's try to solve it. Okay, so the first thing I notice is I only have one real piece of information here. I mean, yeah, they tell me that these two sides are the same, so that means it's isosceles, but I'm going to have to start by using the 125. And if you look right here, we have a linear pair. A line with two angles on it. And we know that those always add up to, wait, are they congruent or do they add up to something? Linear pairs are always supplementary. It means they add up to 180. So what we're going to do is 180 minus 125, and that's 55. Okay, so now we know x. 55. Now, y'all, there's another angle up here that's also 55. Do you see where it is? Okay, this was ask yourself, is that a base angle or a vertex angle? That's a base angle. So there's another base angle. Remember, we have the person with the legs, there's our triangle, the two legs are the same length, and that means the base angles at the bottom are going to be the same. So if that's 55, automatically, because this is isosceles, that's also 55. And that allows us now to find y, because we know that every triangle has 180 degrees inside of it. So 55 plus 55, that's 110. 180 minus 110 is 70, and so that tells us that y is 70. Now we need to find z. Now over here we had a linear pair with 125 and 55. Over here we have a linear pair with 55, which means whatever z is, it would have to add with 55 and come out to be 180. And the only number that does that, we saw it right here, is 125. So we are done. Okay, let's try this one. Again, pause, get the picture down, Okay, and I'm noticing right here, little tick mark, it tells me those things are the same. We're very lucky that in mathematics we have a symbol that means things are the same. And so 2x minus 6 equals x. Let's do a little bit of solving. The way I like to do this, and because I suggest you pause the video, try it on your own, because if you can do it, that's going to build your confidence, and then you know whether or not you need more help or not. Okay, what I'm going to do is minus x, and then what I get is x minus 6 equals 0. Make sure you put the 0, some people forget that. Okay, and I'm going to add 6 to both sides, so x equals 6, and boom, I'm done. If I want to, I can plug it back in. I can do 2 times 6 minus 6, that's a grand total of 6. Plug in a 6 there, that's also 6. That verifies that my result was right. So x is 6, and each side length is also 6. Okay, let's get a new theorem. This one's called Theorem 4-5 in our current book we're using, but it's just the triangle angle bisector theorem. Okay, so the bisector of the vertex angle, whoa. Okay, that's way too much mathy language right now. Let's break this down into something that's smaller and easier to understand. I like it a little better this way. Imagine that I've got a little slice of pizza right here. So, So if we're going to have a slice of pizza, we're probably going to have a little bit of crust. And all this is saying is we're going to slice the piece of pizza in half. Okay, let's connect that to the language. Okay, language said the bisector of the vertex angle. Okay, this is the vertex angle. Bisector means to snip, 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 cut it in half. That's what we've done. Bisector of the vertex angle. So these two sides are the same size. Okay, let's go back and see the language. Of an isosceles triangle, ba-boom, ba-boom, an isosceles triangle is a perpendicular bisector. Okay, hold up. Perpendicular, 90 degrees, cuts in half the base. Okay, so here's how we label that up. Perpendicular, so here's the base, it's at 90 degrees, and it also cuts the base in half. So then I'm going to add these markings that show cuts it in half means we get 2 equal sides when it's cut in half. So cut in half like that. So if you cut the slice of pizza down the middle, these two segments at the bottom are the same, and it makes a 90-degree angle. That's all it's saying, but that's going to be useful in answering some questions. Let's take a look at how we would use that. Okay, so here's our first example for it. Go ahead and write it down. You actually do need the words on this one. If you don't use the words, it's not possible, so make sure you include that. Okay, let's try it. Suppose that the measure of angle L is equal to y. I want to mark my picture in a way that reflects that fact. Y has one angle marker, so L should also have one angle marker. That means if I know what one of them is, I also know the other one, and that's going to be really important. Find the values of x and y. Okay, let's do this. Right now, remember, this is a slice of pizza. We cut the slice of pizza in half. There should be one of the angles on the picture that automatically you know what it is based on what we just talked about. Now it said it would be a perpendicular bisector of the base. That means a 90-degree angle. So that's down here. That means x is 90, and that's also 90. Now, from here, people sometimes can get a little confused because you go, well, there's not enough information. There's no numbers on there. That's okay. We don't need any more information than we have. They actually gave us plenty. Now, if you want to pause the video and try to finish it yourself, that would be awesome. If you pause it and you're getting stuck, then maybe try this. Okay, I'm going to bring this triangle off, and I'm going to write just that triangle down so that that's all I'm focusing on. Okay, and what I know is I have one angle marker up there, and I have one angle marker up there. Now remember, we said every triangle has 180 degrees in it, and 90 of them are right there. And what these two markings are saying is that those two angles have the same number of degrees. And so what we can do then is we can say, let's subtract off the 90, and so we get 90 degrees. That's how many degrees are available to share between these two. And this says, these markings say they're going to share equally. So we're going to divide by 2, and then we get 45. So I know that's 45, that's right here. And I know this is also 45. And check it out, 45 plus 90 adds up to 180, so that checks out. Now, if that's 45, look at this. One angle marker, one angle marker, one angle marker. They're all the same. So what does that make y? That means y is 45. Okay. 90, 45, that's it. Okay. Let's give this a try. Notice again, you've got one marker here, one marker there. Now some people can get confused here because it looks like this marker is bigger than that one. That doesn't matter. What matters is how many markers are. There's one mark there, one mark there. And what I mean by that is, if this had two markings on it, then we say, okay, yes, it's a different style of marking. That means they're not the same size. But having the same number of markings indicates that they are the same size. One marking, they're the same. Okay, so that's 10 degrees. Instantly, I'm going to write a 10 over there because those markings said they were the same. And now we need to find x and we need to find y. With x, notice where the arrow is pointing. It's going down into the corner. With y, notice that it's closer to the dotted line than it is to the corner. So it's saying that that's this angle right here. Now you should be able to look at y and tell us what y is right now without doing any steps, no work, no calculators. That's a perpendicular bisector, and so y is automatically 90. Now on the other side, you should be able to look at this and say, hey, there's a triangle on the left. Let's only focus on the left-hand triangle. You have 10 there, you have 90 there. 10 plus 90 is 100, and we know that every triangle has 180 degrees. So how many more degrees do we need to add to get to 180? 80 more. That means x is 80 degrees. That's it. Okay, let's try this one. Okay, so first of all, what kinds of triangles are they? Look at the marking, compare that to the beginning of the lesson. See if you can figure out what kind of triangles we're dealing with. Okay, these ones are isosceles. Two sides are the same, third side is different. Two sides are the same, third side is different. Why is that helpful? Because if this is 55, there's another angle that you know right now is also 55. Is it x, or is it the corner? Okay, x is the vertex angle. Remember, these are the legs. So that's I'm going to put BA for base angle. The other base angle is down here. So that's 55. Now why does that matter? Because every triangle has 180 degrees for its interior angles. So all we have to do is add those together to get 110, subtract 180, and you get 70. So x is 70. Now it's interesting in class the other day because some people then got really frustrated at this top triangle. There's no numbers on it, so how can you deal with that? Well, we have to rely on logic from our previous units to figure out how to find more angles. The one that jumps out at me is that these two angles are vertical angles. And so that means that this angle is also 70. And if that angle's 70, and this is isosceles, that means these two base angles are the same. So now it's just this same thing in reverse. We know the triangle has 180. We know that 70 of them are taken up, so that's 110. There are two more angles, and they're equal. So divide by 2, and we get 55. Okay? And that's it. Alright, let's try this one. Get this one all drawn out. If you find that you're having trouble understanding it visually, then try turning your page upside down. I'm actually going to do that here. Some students really prefer that. If you don't, then leave it right side up, or maybe you need to turn your phone or your computer, whatever you're watching on, upside down or something like that. Okay, I'm going to turn it this way. For some people it's a lot easier to understand because it relates closely to how we learned it. Okay, it's similar to how we had with parallel lines. If they were like this, we would turn the parallel lines horizontal to the same way that we understood them previously. It's making connections between concepts. Okay, so with this one, now for a lot of people it's a little bit easier to see that we have a linear pair down here. So they must be supplementary. Okay, 110 right there, x right there. So 180 minus 110 is 70. So boom, x is 70. We have a right triangle. And we've got 90 and 70, which means, so I can take 180 minus 90 minus 70 and see what's left over for y, and it's just 20 degrees. So y is 20. Okay, sorry for making it upside down for you, but hopefully if you were struggling, that makes the concept easier to see for you. Okay, and what about this one? Interesting. No numbers given. That can be a little bit intimidating. Take a minute and draw it. See if you can figure out any of the angle measures. You should be able to figure out at least one or two of them right now. Did you notice this little box down in the corner? They're telling us that's 90. We know that every triangle has 180 degrees in it. And what kind of triangle is this? Are two sides the same? No sides the same? Are all three sides congruent? What do we have? Looks like a marking here and there. It's isosceles. So that tells us the base angles are congruent. So if there's 90 degrees there, 180 minus 90 is 90, and we have two angles to share it with, so divide by 2, and that equals 45. So 45 degrees there, 45 degrees there. Okay, that was this triangle. Now how does the triangle on the top left differ from the triangle on the bottom right? This is a square, so they're exactly the same. It's just cut in half. So this part corresponds to one of these angles, which means that x is also 45. Okay? So no numbers were given, but by using our logical thinking skills, we can still figure out every number on the whole picture. I mean, I can figure out then that this is also 45 and this is also 90. That's a right angle. Okay? So our logical thinking can be really, really powerful. That's going to be our last example for today. Until next time, stay mathy, and I'll see you then.